Hi folks, I want to address a really good chapter 1 question that came along about this. How can you tell the shape of a distribution if it's not a histogram? You've seen a few problems in chapter 1 now, so I think it's good for us to go back and really dive into those, and let me give you some tricks. This one right here, you might remember from 1.2D when you had to upload your work about Bonds and Aaron and their home runs. And one common thing a lot of folks missed out on was what was the shape of the distribution. So clearly this is not a histogram, this is a stem and leaf plot. So the easiest way to tell, because this is very similar to a histogram, but this one was tricky in two ways. First thing you wanted to do is if you look at Aaron and what the shape is of it. Because the distribution is going vertical and not horizontal, what I was recommending to you is to take this and to flip it so it looks horizontal. Now be careful, the low end here, this is the 10s, the 20s, and the 30s. I didn't bring those digits over. So here's our 10s, 20s, and 30s. So now if you trace over it to kind of get the shape and look for the tail, on this one it's a little bit easier to see. We're going to go up here, come back down, and you may not think there's a major tail here, but if there is a tail at all, it's going to be somewhere in this avenue of it. So in terms of the definition, this is going to be skewed to the left because it's on the left-hand side of the tail. So Aaron's is skewed left. Now when you look at Bond's distribution, the one thing you have to be careful of is when you take this vertical one and you make it horizontal, that this is the 15, there's 26, there's 34. So this has to go on the left-hand side. So you're going to see me right here actually transpose it and do a flip. The digits look backwards, but just bear with me on that. So here is the 15, the 26, and the 34. So now when you look at it in that orientation and you follow this, hopefully, again, you can see it's not that extreme, but there is a little bit more of a tail on the left-hand side. So both of these stem plots happen to be somewhat skewed left. And as you get better at looking at these various stem plots, it's a little easier to look at it vertically. But again, suggestion here is to go horizontal with the data to see it better. Now, this one is a nice example I actually teach in my function stats and trig class, where they are given 3 different histograms and they have to equate which box plot it would be. Now, from the past free responses I've seen from the AP board, I have seen cases where they give you the box plots and you have to describe the distribution. So that's why this is a good one. One of them that's pretty easy to see if we start here, clearly this histogram is somewhat symmetrical. If you had to pick the box plot that equated with it, hopefully you see the connection that C goes to box plot 1. I think the key thing here to help with that one is obviously symmetry, things are nicely balanced. We see this box plot is nicely balanced. Now keep in mind on a box plot you do see it quartered off, so from here to here is 25% of the data. This part of the box is 25%, another 25%, and another 25%. So you see this chunked off in kind of somewhat equal 25% chunks. Now let's look next at histogram B. So in terms of words, histogram B, if we follow the tail, would be skewed to the left. Which one of these box plots is skewed to the left? What you're looking for is something that may have a potential outlier on the left. So somewhere there's a nice big pull. Histogram B is actually going to go to this box plot number 3. Here we have, remember, if we think of the 25% of the data, 25% of the data is there, 25 is here, another 25. So really what you're seeing is 75% of the data is on the right-hand side of this graph. Well, if you look over here, almost 75 or most of that chunk is on the right-hand side of the graph. And then what happens is there's a pull here because there's a potential outlier that could be out here. So what we're seeing in this case is this here somewhat equates towards that end of the graph. Then the last one we have, clearly histogram A has to go with box plot 2. A good way to see that though is, remember the box itself, when you look at a box plot, if we just sketch one, this box right here, the middle box, is 50% of the data. So the middle 50% of the data is there. Well, in here, the middle 50% of the data is all right in here. It's crunched together. That's why you see this box so tightly in here. And then this little guy right out here is actually this outlier. So in here, it's also condensed, and there you see it all condensed in a really short box. And if we talk about the shape of this distribution, if we follow histogram A, we have to go all the way out here. Clearly, this is skewed to the right because the tail is over here. And again, we can see that skewed to the right within the box plot. So hopefully this helps you understand more about the shape of the distribution if you're not given a histogram or a bar graph. Let me know if you have further questions on this. I can help you out individually.